So, what do artificial intelligence, a championship sports team, and your own health all have in common? Well, it might sound a little strange, but the answer could totally change how we predict one of the world's most widespread silent diseases. Turns out, it all comes down to a powerful AI technique that works a lot like a team of experts. Let's break down how it works.
It all starts with this number right here. More than 10%. That's a huge slice of, well, pretty much anything. But what does it actually represent?
That's the percentage of people all across the globe who are living with chronic kidney disease, or CKD. And the really challenging thing about it is that it's often completely silent. You might not even know you have it until your kidneys are already in some serious trouble.
So, here's our game plan. We're going to start by understanding this silent global problem. Then, we'll look at why it's so hard to predict. After that, we'll dive into a fascinating new AI solution, explore the power of teamwork, and finally, see what this all means for the patients at the very heart of this story. All right, first up, let's really get a handle on just how big this problem is. We're not just talking about a statistic, this is a personal journey for millions and millions of people.
So for anyone who gets that diagnosis, the one question that just hangs over everything is this: how quickly will my kidneys get worse? It's a question just filled with uncertainty, and getting a clear, accurate answer is absolutely crucial, not just for treatment, but for peace of mind.
And that right there brings us to the core medical challenge. See, doctors have tools to try and predict this, but they're not perfect. So why is it so incredibly hard to forecast something like kidney failure with real precision?
Right now, the standard tool doctors use is called the Kidney Failure Risk Equation, or KFRE for short. You can think of it like a calculator. It takes in a patient's data and then spits out the odds of kidney failure over the next 2 to 5 years, and it's been a really valuable tool in medicine for quite a while.
But here's the catch. The KFRE is kind of a one-size-fits-all model. And as we're learning, its accuracy can really fall short when you apply it to different groups of people around the world. For instance, studies have shown it's not nearly as effective for patients in places like Southeast Asia. This gap creates a huge need for a more personalized way to predict risk.
And that is where our story takes a turn, because a new study out of Hong Kong decided to tackle this problem head-on, using the power of artificial intelligence.
So researchers there ran this huge study. We're talking analyzing more than 34,000 patient records using some really sophisticated AI models. Their goal was super clear. Could they more accurately predict which patients would eventually need dialysis or a transplant, and could they predict mortality risks too?
And the results, right out of the gate, were really promising. The AI model they built showed excellent performance, especially for predicting what might happen in the near future, like over the next 1 to 3 years. A fantastic start for sure, but the real breakthrough was what they did next.
This is where we get to the secret sauce of this whole thing. See, the researchers didn't just stop with one good AI model. They figured out how to unlock something way more powerful by getting their AI models to work together as a team.
So, that's the big question, right? If you already have a good AI predictor, how do you make it truly exceptional?
Well, the answer is a technique called model ensembling. And what's cool is that the logic behind it is actually pretty simple. Instead of just relying on one AI's opinion, you combine the predictions from a bunch of different AI models to get one final super-powered result.
Think of it like putting together a dream team of medical experts. First, you train a diverse group of AI models on the same patient data, so each one develops its own unique perspective. Then, for a new patient, you let each of those AI experts make its own prediction. Finally, you just average all those insights together. The result isn't just a guess, it's what you could call a super prediction. And you can really see the difference it makes. A single AI model? Yeah, it can give you good accuracy. But the team, the ensemble, that's what gets you excellent accuracy. It takes a strong prediction and just makes it way more reliable, because where one model might have a blind spot, another one sees clearly. And when you combine them, you cancel out those individual errors.
Now, what's really fascinating is seeing this play out in the actual data. This chart shows that as the researchers added more AI models to the team, the overall accuracy just kept getting better and better. It shoots up at first, and then it stabilizes at this incredibly high level. And this is the peak number they reached for predicting the need for either dialysis or a kidney transplant, 0.98.
So, what does that number actually mean? It's a performance score called the concordance index. Basically, a score of 1.0 would mean the model is a perfect oracle. It never makes a mistake. So hitting 0.98, That's not just good, it's unbelievably close to perfect. It means this AI team can predict the future for these patients with just remarkable precision.
So, that's an incredible result. But let's bring it back from the lab to the real world. How does a finding like this actually translate into something that could change lives? What does it all mean for patients?
Well, the researchers themselves really said it best. These models offer a personalized approach to patient management. So instead of that one-size-fits-all equation, doctors could have a tool that gives a prediction tailored specifically to their patient in their part of the world.
Okay, let's pull it all together. First, we've seen that AI trained on local data can create predictions that are way more personal and accurate. Second, this idea of teamwork, of ensembling, makes these AI models dramatically smarter and more reliable. And what that all leads to is better care, helping doctors make proactive decisions for their patients, and it can even help hospitals use their critical resources more effectively.
This research really takes us beyond just algorithms and data. It paints a picture of the future of medicine, one where AI isn't there to replace human expertise, but to be its most valuable and collaborative teammate. And that really leaves us with a powerful question to think about.